Oh, now I see the problem here. So instead of subtracting the row, I'm just adding the row to the results. So that's why it's giving us false results. Sorry for that. Okay, so after subtracting, let's see how it goes. Okay, so enter the number of unknowns again. It's getting a bit repetitive. Okay, now you can see that we have our triangular form here. So it is doing a bunch of swaps and making these diagonal elements into 0. And we've basically almost solved this equation. So from here, you can actually go get a pen and paper and solve for the equation yourself. You don't need a computer to do it, but I'm just going to do it anyway. So, um, okay, so I'm just going to add these back substitution program where, so it finds out that, okay, 5.4z equals 1. So then we divide this by 5.41 to isolate the z variable. Then I'm just going to plug it back in, and then we will have our y variable, and then we'll have our x. And after that, we print it out. So probably okay, so we're almost done here. So once the matrix is in the upper triangular form, we solve for the variables using back substitution. Starting from the last row, we have already isolated it. We solve each variable by dividing the constant term by the pivot. So the pivot is the diagonal element. So we divide by the constant term and then substitute it back into the equation above it. So that's why we have j equals I plus 1. So we're going the above row to substitute this value back in, which is going to be 1 divided by 1.6 divided by 5.41. And we'll just doing it over and over again until we reach the top row, and then we'll have our um, x, y, and z. And notice that I have also actually declared a new result array that stores um, all the results, our solutions for x, y, and z. And we need a few things to do with the main function. So let's declare our result array, which is float result. Initialize it to max because why not? So after Gaussian elimination, what we're going to do is max substitution. Okay. Now we use the matrix function again to see the result. No, we don't need to use the matrix function. Sure, we need that. Okay. Now we run this program for the final time and let's see how it goes. Okay. Okay. So you can check with the calculator to see if this is okay. I already know this. It's okay. So um, we have made these three things 0, and then we do back substitution, and we find out that x1 is negative 0.123 1292, x2 is this, and x3 is that. So this is a lot of work, but I think that if you have a good understanding of how you solve systems of equation with augmented matrix and Gaussian elimination, then I think um, if you type it with me, I think you will be able to understand what's going on here. It will take a few tries, but this is a nice project for a beginner. I mean, I'm learning how to code and making this really help me understand things better. So, uh, goodbye.